Okay, so can you do like a 1-minute intro about who you are? You don't have to say anything specific, and then we can get started.
Sure. Hello, my name is Sakit. I'm in my third year of computer science and engineering. I'm taking this interview just to get an idea of where I stand, if what I prepared is enough or not.
Okay, cool. Okay. Yeah, so the first question is going to be, you are given a string, S, and a array of words. And I want to know if it is possible or not to build this string out of words in the array. So for example, if I'm given leak code is the string, and the words is the and code, then this is true. But if I'm given leak code and I have like this, for example, then this is false. And you can feel free to ask me anything you want to.
Okay. Okay, in the same example, what if the string is code lead? Will that work also?
Yeah, so the order doesn't matter. It's basically, can you just use the words to build the string?
Okay. And what if the string is empty or the word array is empty? What do I do in that case?
Yeah, so if the string is empty, it's going to be true because like you don't need to use the words. You don't need to use all the words. And if the word dict is empty or the word array, and you have a string, then you obviously can't build it because you don't have any words.
Oh yeah. If both are empty, then it's going to be true, right?
Yeah.
Okay.
And also you can reuse the words.
Okay. All right, so I'm given a string and I have to find if it is possible or not to build the string using any words in the array.
Yes.
Okay. My initial thoughts are
and by the way, so we're going to go until 4:25 PST my time. That's 50 minutes.
Okay.
Cool.
Yeah, initially I'm just thinking to go through each word in the words and in a loop try to build S for each word, like kind of like a nested loop. Okay, it wouldn't be nested, like a recursive loop.
Okay, so you're basically saying take words and just try to build it. Take words and try to build. So what would be the time complexity of that if you did that way?
Okay, if you're doing it like kind of like backtracking, let us say if I'm at lead, I can choose it or not. And if I'm at go, I can choose it. I can choose it or not. It would be 2 power n, where n is the length of words.
Yeah, well, you can also use the word multiple times too. But yeah, I agree. It would be like exponential, some kind of exponential thing. Yeah. So can we improve on that?
Maybe we could add memorization like 40p.
Okay.
Let us say yeah, the DP state, or let us say DFI would be given a string, like a part of the string.
Okay.
The part of the string and index I. Can I build the next suffix of the string starting from this index?
Okay. Yeah, makes sense. And what would be the time complexity there?
I think it would be O of n there,
So what is n?
because n is the number of words.
Number of words. Okay. Let's see. So O of n. Um, so what would this look like? Like, can you give me more details? I guess.
Yeah.
Okay.
Initially, I would just call like an empty string, I would say, and the index 0.
Mm-hmm.
And for PP, parent string and index. Yeah, if I is out of bounds or the current string, um, oh, yeah, if I is out of bounds, we just return.
Out of
And
bounds? Like, what do you mean out of bounds?
like if the I is greater than the length of words.
Greater than the length of words. Okay.
And yeah, for each thing we check if the parent string is equal to the string, the target string. If it is yes, you can just return true there.
Okay.
Mhm. If not, I guess we can reuse the words, right? Okay. Oh, if you're using the words, uh, only checking I wouldn't be enough. Mm, Just give me a minute.
Mm-hmm.
I think what we can do instead is uh, just a vague idea. For in a for loop, we can go through each word and yeah, let us say for lead code, the first word I chose is lead. Okay,
Mm-hmm.
let us say I chose co first, and I would compare since the length of co is 2, I would compare the first two characters there. Since it is false, I go to the next one. Let us say the next one is lead. I compare this length with uh, the corresponding characters of string. It matches. Um, so yeah, I start from the index of C here, and yeah, then I continue try and finding that in words.
Okay. So what does your DP function look like for that?
Yeah. Um, mm, we could just say if word is equal to mm, yeah, if L is the length of word,
Mm-hmm.
and yeah, I would be the current position where we are at.
Mhm.
You can check if s of I to I plus L. Mm, Do I need a plus one there? I don't think so. Yeah, if these are equal, we can call DP again. Um, would I need current string? Yeah, I don't think I need current string. I'll remove it for now.
Okay.
Yeah, we could call DP of uh, I plus L. Yeah, if we are yeah. While doing this, if I equals the length of S, I think that means that oh, the length can be. Oh yeah, if I equals length of S, I think that we have successfully built S from words. I can return to that.
Okay, so basically, like, if you get to the end, then it's true. Otherwise, you're gonna check for every word. If it matches, then you're gonna like recurse to the next part.
Yeah, if it overshoots, like if I goes greater than length of S, we just return back. Return false there.
Okay. Okay, this makes sense. So what's the time complexity of this?
Okay, here. mm, mm, yeah, for every I think it's possible to go through every word. Mm,
Hmm.
think it would be like yeah, I think it's going to be like the length of S into the length of words.
Okay. Okay. And then what's the space gonna be?
Space is going to be since there are BP states here. Uh, mm, yeah, I think the length of words.
Okay. The length of words for space. Okay, got it. Okay. All right. I think I'm good. I understand what you're doing. So we can start coding. I think.
Okay. Mm, I'll just pass S also here.
Okay. Well, so you want to have like the starting function, right? So you need a function that takes in a string and an array of words. So whatever you want to, like however you want to write that, that's fine. But you need like an outer function.
Okay, okay. Um, Mhm. I think this works. For the initial index, if the word matches here, we return the DP of I just to check the future possibilities.
Mhm.
If none of these work, it would be false. Mm.
Okay.
Am I free to run the code?
Yeah.
Okay.
I guess you never printed what it returns.
Oh, yeah.
Okay.
Mm, okay. Mm, oh, I don't think I accounted for the empty string and all. Let me just check that.
Sure.
Mm, yeah, if S is empty, why would it be true if words has some words? Because I'm not using any of the word here, right, to make
Yeah,
S.
that's still valid because like you don't have to use the words.
Okay, okay.
So that makes sense.
I didn't know returns true, but I'm just trying to.
Sure.
And yeah, I just want to be explicit here. And words. Okay.
Okay. Is there anything you're missing in your DP function?
Mm, yeah. Do you mean like memorization?
Mm-hmm.
Let us see how I would add that. Yeah, I think this is fine.
Okay, so you are still missing something with memoization.
Oh. Yeah, first the call goes here. Then if I use an yeah, I was not using the mode of it. I just had it declared.
Yeah, you're still missing one more.
Will it be here?
Mhm.
Memo of
Okay. I think this is good. I think we can move on to the second question.
okay.
Okay. So in the second question, all right. So you're given a network of nodes. So basically, you're given n, and nodes are labeled. So this is like the number of nodes you have. You're also given an s, which is like the start node, and you're given a list called times, and times has a time, a node 1, and node 2. And so basically, times tells you how long it takes for a signal to go from N1 to N2. And so the signal starts at S. So this is actually a start node. And I want to know how long it takes to get to all nodes, or -1 if not possible. So to give you an example, if our times looks like, right here, I can just paste this. So for this, if n is 4, and so I guess it would be the other way. So it wouldn't be 2 to 1. It would be like 1 to 0, 1 to 2, and 2 to 3. And this is start node. So in this case, we're going to get 2. And that's because, or actually, let me see if I did that correctly. No, this is actually 1. So basically here, it starts at node 1, and it takes 1 second to go from 1 to 0. It takes 1 second to go from 1 to 2. And then once it's at 2, it takes 1 second to go from 2 to 3. So the total would be 2. Does that make sense?
Yeah, here initial node is S, right? I mean 1.
Yes.
But we are not starting from 1, right? We're just starting from 0.
No, you start from 1. So times is just a list of, if you want to go from one to the other, this is how long it takes. But you're starting from S. So S is your start node.
What if there is no time for 2 nodes? Let us say some 4 and 3. Do I assume that they are not connected?
Yeah, so if something's not connected and you can't go from the start to the end, then you would just return -1. So for example, if times was like empty and same question, you would return -1 because like you can't go anywhere. So this would be -1, this would be 2. Does that make sense?
And yeah, is this directed? Can I only go from N1 to N2?
That's
or
right.
Is it
Yeah.
is the reverse pathway?
Directed.
Okay. Yeah, in that case, here S is 1, right? And here N1 is 0, and N2 is 1. So how can I go from 0 to 1?
Oh, I'm sorry. So yeah, you're right. So it should be the other way. Yeah. So sorry about that. Okay. So yeah. So you can go from 1 to 0. Or I guess it would be, yeah. So it'd be the other way. So 1 to 2, and then yeah. So I got it backwards. So I think it would be like screw this up a little bit. So it would be, this would be 1. This would be like this, right? That's correct now, I think.
Okay.
Okay.
Let me just try some. In this case, the answer would be -1, right? Because there's no starting node as 2.
Yes. Yeah, because here you can only go from 1 to 3, and you need to go to, so here you need to go to 0 to 1 to 2 and to 3, and 2 doesn't go anywhere, so yeah, you would just return -1.
Okay. Yeah, I'm just thinking that we could initially form a kind of an adjacency list for each node. What are its next nodes possible, along with the times, and yeah, starting from S, we could do a kind of a DFS. Yeah, do a DFS and check if the total number of nodes that we encounter is equal to n.
Okay.
Oh, we need to keep track of the time. Okay. For keeping track of the time, maybe we could have some other data structure where each time I encounter a new node, that holds like we can have a max time variable, let us say, and each time I encounter a new variable, I take max time equals max of max time and the time required to reach that node. It at the end will end up with the max time.
Okay,
Um,
so the max time is max of what? Sorry. Oh, I see. Max time is
Max time
okay.
is
Okay, got it. Yeah, yeah. Okay.
max time and
Mhm.
sorry, I-
Okay, and you said you do a DFS.
yeah.
Okay. So DFS would basically get to a like. So because you have a time, you can have a ton of edges, right? You can have like n squared edges. So if you get to a node, you can get to a node in like a bunch of different ways. So how do we ensure that we like get there? Um, like let's say we can get to a node in like 10 ways, and like they're obviously different times. How do I ensure I get there the
Oh,
fastest?
oh yeah, yeah. Yeah, I have to. Uh, mm, yeah, time cannot be negative, right?
Your what? Sorry.
Time
Yeah.
can it be negative?
No, it can be 0 or positive.
Okay. In that case, I think I have to do in a Dijkstra, apply Dijkstra algorithm for the starting node,
Mm-hmm.
and yeah, that will make sure that the all nodes that I reach have the minimum time, and I can still maintain the max time variable to find out the maximum time among all the nodes reached.
Okay. Yeah, makes sense.
Mm, yeah, initially get the adjacency list, and what would I need here? Mm, I can maintain a visited array to check if I have visited a node or not.
Mm-hmm.
Mm, if that particular id is then visited, just kill. Yeah, and for Dijkstra, we would also need a minimum heap, right?
Mm-hmm.
So that we can go to the next best node. Mm, second heap. Mm, yeah, here, N2 would be the destination node.
Okay.
Yeah, here where is it? Required time is the for it's a dictionary where for each node I maintain the time needed to go there,
Okay.
and yeah, the new time is going to be minimum. Minimum if that new time is less than whatever is was there in the required time. Yeah, then required time is going to be like it is going to be this plus the required time of getting to I, right? Mm, yeah, I have to account for the edge case of initially if there is no N2. What do I do? Mm, yeah, if N2 is not in required time initially, uh, I would just add this new time in that and continue with the minimum.
Okay, so the required time is like how long it takes to get to a node. So you're basically saying new time is heap hop. Okay, if not to. Oh, I see. Okay.
Okay.
Okay, I see.
Mm, and I would need to add all of the nodes, the destination nodes possible to reach from N2 back into the heap.
Mm-hmm.
Let me just complete this. Then it is fine to add it here itself. Mm. For okay, if new time into uh, mm,
Okay, we have about 10 minutes left.
Okay. Now I'm thinking whether this should be here because let us say I push a new node into the minimum heap.
Mm-hmm.
We would get the next uh, node and time pair right here, right? So I just check it here, I believe. Like once I get this, F N2 was visited already. We just return. Yeah, our piece can be inside.
Okay.
Yeah, I have not implemented adjacent here, but it would just be in a loop, go through times and for each source node add time and destination in that.
Okay. Yeah, so maybe we can. So, what's the time complexity of this going to be?
I think it's going to be like e plus where e is the number of edges, e plus v times log v.
A plus v times log v. Okay.
E.
Oh, times log e. Yeah, I think that makes sense.
Yeah.
Okay.
But I'm still not having the max time variable.
That's right. Yeah, you don't have it.
But as 0, I believe. Yeah, I think at the end I will just return max time.
Okay. Okay. Yeah, maybe we can try coding this and see if we can get like a test case working. In time we have left.
I think I can just Mm. Why does this give an error here?
Oh, it's because you did that. You imported default dict, not collections.
Oh, okay, from collection support. Okay, fine.
Mm-hmm.
Mm. Oh, I'm still not checking for the case where it is not possible to go to every end.
Mm-hmm.
I guess initially we can keep -1. Mm. Yeah, maybe while returning here, we can check if the number of trues in visited equals n. We can return the max time. Otherwise, return -1.
Mm-hmm. Makes sense.
Mm.
I think we have like a couple of minutes left, so maybe you can just like copy it over and see if it's working.
Okay. Mm. Mm.
Okay, I think we're like a couple of minutes over, so let's just stop here.
Okay.
Okay, so how do you think you did? What do you think you did well? What do you think you can improve in?
I think I took too long for each step of the process, maybe explaining or coding up, and I could not come up with a solution very fast.
Hmm. Yeah, I
Um,
think so I can give you my feedback. So I think in the first one, you came up with like good edge cases and you came up with a couple approaches. So you basically said you could do a backtracking, you could do DP. But I think you were like doing it the wrong way, but then you figured out like how to do it better. So I think you were trying to do something else, but then you ended up like getting to the right thing. You also, so I asked you, well, like, what's the time complexity? And you said it's the length of the string times the number of words. So if you actually look at your code, which is here, I think. So it's actually like at every single place, you have to actually compare the word to. So it wouldn't be length of the string times the number of words. It would also be like the comparison. So it'd be like times the length of the
oh,
word.
yeah.
And then for the space, you said it's O of the number of words, but it would actually be O of the length of the string because your memo array is like index based. So
Oh, yeah.
yeah. Um, but I think, yeah, basically, I think the things you didn't do so well is I think you definitely had a lot of like quiet times where you were like either coding or something and you just like kind of like stopped talking. And then also for the speed, yeah, definitely for the first one too, you could have done it a little bit faster. And I would recommend like in the plan, like the pseudocode thing, I don't think you have to write the entire function. You just like summarize it like really quickly. Because you were basically like writing the entire code like in the comments and then just like copying it over, which I think it's just better to write a couple lines of like this is what needs to happen and then code it in the code. Um, instead of just like because otherwise like you're just writing it in the comments and then pasting it over, you might as well just like write the code itself. Like it doesn't really make a difference. So
Oh, yeah.
yeah, so I think that would have been better. And then and
Mm.
also for testing, so if you do run your code, I would recommend uh, not deleting previous test cases. So you like wrote one and then you like deleted it and then you like wrote another one and deleted it, because that way let's say like after running 5 test cases the sixth one breaks, and then you have to go change your code. Well, how do you know that like the other ones still work? So I would recommend like writing test cases one by one, making sure they work, but keeping them all there. That way, if you change your code, all the previous stuff still works. So that would have been
Mm.
better. So
Mm.
yeah, I think for the first one, I kind of gave you like a somewhere in between, like a lean higher to lean no higher, because you did get a solution and it was good, but you took a while and like yeah, basically your thought process wasn't super clear a lot of the time. So I definitely think you can improve there in terms of like speed, talk more, and then yeah, in the coding, basically just like also yeah, I think you were actually I think maybe your coding I could have graded a little bit higher because I didn't really know what you were doing. Like you just wrote a DP function. I'm like, are you gonna write like a main function or something? But it ended up working fine. Oh yeah, the other thing is like you forgot the caching completely, and then I told you to add it, and then I still had to be like, oh, you're missing this, you're missing that, you're missing that. So definitely review like where to add the caching and like where it needs to be, because I feel like if I gave you a hint that you forgot something and then you do it and then you're still missing stuff, then that's not great. So it's a small thing. I think it's very easy to add caching to DP, and like ideally, I don't have to remind you to do it. Um, and then let's see for the second one. Yeah, so you stated the problem. You asked about constraints, directed graph. You said DFS, and then I was like, well, how do we know that like if we get to a node multiple times, how do we get there the fastest? So you did figure out Dijkstra's, but then you really so once again you wrote the entire code like in like the comments, and you really shut down in terms of communication. Like I feel like you had a lot of quiet time, and I really wasn't sure like what are you doing exactly? Like I don't know if this is gonna work. So I would basically review these algorithms, especially like Dijkstra. Look up like what's get a working solution. Like let's say you end up fixing this, feed it into Claude or whatever, and then just say like how do I clean this up to make it like as readable as possible, get rid of like everything unnecessary. And I think that's a lot of feedback I give a lot of people is like you don't just want a working solution, you want a working solution that's like pretty readable and is very easy to understand. Um, so
Mm.
you had a lot of parts that were like you had like required time 1, required time 2. Like basically for Dijkstras, all you have to do is just like so the other thing is like you're visited and your I don't know if you recognize this, your visited and your required time could basically be like you don't need a visited. Your required time is a visited essentially. So what you could say is like I save required times, and then when I put things into the heap, if the required
Oh,
time is lower than I had, then I'll add it in. And if it's not, then this is like a bad path, and I'll just not have it. So you can basically get rid of this altogether.
yeah,
And
I
then
see that.
yeah, and then that also minimizes heap insertions where you don't check for visited. You only add to the heap where like that path is shorter. So that's like ideal Dijkstra's is you check right when you add to the heap, like is this going to be shorter or not? And then that would also make your code cleaner, would get rid of a bunch of like unnecessary stuff. And then yeah,
Mm.
because you definitely slow down a ton on the second one. Like you were writing this like I feel like we started this with like 30 minutes left or something, and you were taking a very long time writing this thing. So maybe like haven't done Dutch in a while, maybe you're like unfamiliar, but I would definitely review this. And yeah, basically this the what you could have done instead of writing all this is you could say like, like real quick, like create adjacency list of a node to like child dist, heap starting at start, and then have a dict of node plus shortest dist to it, and then just like traverse heap, add to heap if dist is shorter than I have stored. And then you can basically just say return length of whatever this what do you call it, like rec or something? Yeah, rec time equals n, right? Because that means you visited every node successfully. And yeah, so definitely cut down on like your code and make it like as readable as possible. Not just have like a working solution. And I think you get better at that just by like practicing on like LeetCode or whatever, and then taking your code and cleaning it up and making it like as good as you can. And the other thing that helps for that is the easier code is, like the less variables, the less unnecessary stuff, the less likely you are to make mistakes, and the more likely it is for the interviewer to understand what's going on. So like you can have a working solution that's super complicated, and then it's pretty likely you're going to make mistakes and it's going to be hard to debug and stuff. So yeah, basically I think I like rated your DSA as like okay, your problem solving is okay, and then the thing think the things you need to work on is like yeah, basically coding, and then speed. Speed was another like really big one. Like it was just too slow. So that's why you want to write a plan that gives you enough to have a clear idea of what to do. So that way when you're coding, you're not thinking too much. You just kind of know like, okay, here's what needs to happen. Like if you're almost always just like, man, what do I do here? What do I do here? And it takes forever, then that's not good. And then also you need to like maybe practice that type of problem more. So yeah.
Yeah, I think what happened was I just when I do lead code, I don't have to explain the solution to anyone else, and like my variables and my method of doing it makes sense to me.
Right.
Yeah, I think that's where communication lacks, and I have to speak more while coding. That also hindered my thought process.
Yeah, and that's very
Yeah.
common. Like a lot of people just like do stuff on LeetCode. LeetCode gives you all the examples. You don't have to ask anything; it's all there. It gives you the constraints, which no one's going to give you. You don't have to explain anything. You can use random variables that don't make any sense, and whatever. And then all the test cases are given for you. But in real interviews, you have to be able to communicate. The person has to know what's going on, and like you have to actually ask the constraints yourself. So it's like a totally different experience. So I would recommend coding in a non-LeetCode editor once you're like good with the problems, and like maybe either recording yourself or writing down your thoughts and just like feed it into an LLM and be like, here's my thoughts for, like literally you can break it down into like clarifying questions, plan, code, testing, and then either write it down or yeah, basically just feed each part into an LLM and be like, or grade my response for this stuff. I literally made a video on this where you just like tell an LLM like ask me a question, and then you give it a prompt that says like I'm going to do into these parts. I'm going to give you each part, and then you tell me if it's good or give me a hint if I did something wrong, and then like keep going. And then that way it's not like you don't want to be relying on LeetCode. And the other thing, make sure if you have to make classes or functions or whatever, make sure you can make those outside of LeetCode. Because if you don't know, like if I say you have to make a class that does some stuff and you're like a lot of people ask like, well, can you give me like a template for the class? It's like, well, can you not write a class? Like, so definitely don't rely on like everything being in LeetCode. Make sure you can write stuff yourself from scratch. Because you want to show like familiarity with the language. Like if you can't write a class in Python or like functions in Pythons or inner functions or whatever, then that's not good. Does that make sense?
Yeah.
Okay. Do you have any other questions, or is this pretty clear?
Yeah, I think I'm good. Thanks for the interview.
Okay, yeah, no problem. And then you can feel free to schedule another one if you want to down the road. I think basically I just tell people don't schedule. Make sure you have like a month gap so then other people can sign up because I'm like booked for like 3 weeks or something. So yeah, if you want to schedule more in the future, feel free to do that.
Okay, for sure.
Okay, cool. See ya.
See you. Thank you.
Uh-huh.